Welcome. I know chapter 8 talks about strings as well, so I wanted to make a separate video for strings, and that's what this video is for. So we're going to create a program that is chapter 8 strings.cpp, and we're going to really talk about two different kinds of strings. One is the modern string object, and the other is the C-style character arrays, which are like character strings. So at the root of a string is an array of characters, and so there was a way to handle that array in the past that was immutable, like an array, like the ones we just learned about, and we've modernized that a little bit in modern iterations of C++. But to do this, we're going to include a few libraries. So we're going to include IOStream. We're going to include string, and we're going to include CString, and we're going to talk about the string class first. Let's go ahead and create a main method. Let's go ahead and create a main method, and here again we're going to put that return so we don't forget it. Alright, here we're going to say the name we're going to look at is Alice. And if we output this name, we've done this kind of thing before, but if we output this name, you will see that the name that is output is Alice. So we're going to G++, chapter 8, strings.cpp. Never saved the file, so that would help. There, now chapter 8 strings is saved. -o chapter, we'll just say C8 string. There you go. No, because I did not put an L there. I don't know why I keep doing that in my head. Oh, more importantly, I did not use namespace std. That should fix those errors. Yeah, okay. There we go. Let's compile that. And C8 string. There you go. Name is Alice. Right? So, this kind of string, the string name equals Alice, can easily be reassigned. I can now say name equals Bob. And if I output that again, you will see that name was given a new name. There's the new name, Bob. Okay. So there's a few common operations you can do with strings. You can concatenate easily with plus. So I can say, okay, we can say name plus equals let's do it this way. We'll do it. We'll create a new string. String full equals, let's do it this way. String first equals hello. String second equals world. String full is going to equal first plus, we'll put a space in there, plus world. Now, when I output this, I can say output full, and you can now tell that this has been concatenated. Alright, so there's hello world. Okay, so there's another thing that we can do. We can find the length. Unlike arrays, there is a native length in here, and I can say full length, and that full length is going to be from full dot length. Okay, cool. Let's go ahead and see how that works. You can see the full length is 11 because you start with HELLO, which has 5. There is a space in the middle, which is 6, and then 7, 8, 9, 10, 11 for world. So we have length, and we can also compare. It's a little different if you're used to Java. You can compare these strings with the double equal sign. And I will just say full equals equals first. Got a lot of errors there. That was fun. Let's do it this way. Versus me working that, we can say if first equals equals hello, then we can output first is hello. Alright. I wanted to output the Boolean. It didn't like that in C++, so we're not even gonna mess with that right now. I'm going to clear our terminal, and we're going to run this. There it is. Alright, first is hello. So we've done a comparator, a direct comparison using equals equals, which feels a little strange, but that works in C++. Alright. Now that we know how strings work, let's talk about C-style strings. These are character arrays that are terminated by a null character, which in string land it would be \\\0. But unlike string, C-style strings don't grow or shrink. They are immutable, so they need to be big enough to hold all the characters and the null terminator. So instead of saying first, for example, we can create a string that looks like this. We can say car C string 1 10 equals hello. Now obviously here we can't concatenate this anymore because this is a C string and this is a string, and you can't modify a string, right? But I can output just first, or just C string 1, right? So let's look at how to do that. I can say, okay, let's output the C string and we're going to go ahead and take all of this out because that was part of our previous iteration and we don't need it anymore. But let's do this, and you can see the C string does output the entire string. Okay, so we can use functions from C string to manipulate C style strings, and let's talk about how we can do that. So here we have, I'll create another C string, so we'll say C string 2, we'll make it 10 as well, and we're going to make that equal world. String second, we will get rid of it. And we're not worried about Bob or Alice anymore. So we'll leave them there anyway, it doesn't really matter. So to concatenate in C-string, we have to use this method, which is strcat, like string catenation. And we can put string 1 and a space. Sorry. C string 1 and a space. There it goes. So what I've done is I've added a space to the end of that character array. Alright, how does that work? Well, remember that I gave this 10 spaces, so I can modify individual elements in the array. But I can't change the size. I can also, for this other world, so if I go to string cat and I append with C string 2, I can append, let's do it this way, string 1, and we will do C string 2. Well, here's a question for you. C string 1 has 10 characters. Hello world, we know from our previous iteration, hello world's put together has 11 characters. So I need to modify the number of characters here to accommodate that new addition on the C string. Alright. And to kind of show you what that looks like on the concatenation, I'm going to go ahead and output the length. So here is my length of this string. Okay, so let's output this. And you can see that C string hello world does have a length of 11. It did concatenate it, but just remember to be careful, because strcat doesn't check bounds. String catenation doesn't check bounds, so always make sure you're allocating the space, just like we modeled in this video. You can also compare strings. So I can compare C string 1 to C string 2, and I can compare them using a comparator, which is just string compare, like that. And I would compare the two strings, so string 1, C string 2, and what happens is, how do I explain this? Kind of explains it here. If well, basically, it's going to return a 0 if they're equal and a 1 if they're false. So we're going to output that to the user. Strings are equal. Else. Strings are different. There you go. Alright, so what this should output is strings are different. Because they are. If, however, I set, well, I won't mess with that, but just so y'all know, that's how that looks. Okay, so the difference between string and C string. C string is resizable, or I'm sorry, string is resizable, C string is not resizable. Operator overloading in C string happens so that plus concatenates. There's no operator overloading in C string. You have to explicitly call that string compare and string cat method. And C string is slower. So the initial string themes we talked about, the modern string stuff, is slower. The C style string is faster, but it is riskier. And I'll just tell you that you should use the new strings for almost any text processing, unless you have a legacy API or need raw character arrays. I don't ever really use C-string in the modern era. Just wanted to show you that it exists and it's also in the text. Alright, if you ever need to mix the two, you can convert between them. And let me just jump in and show. I'm going to delete this. Well, I'll just comment it out right now. I always hate to delete code. I feel like there's a reason I wrote it. Why not keep it? So we're going to put that there to comment that out for now. Okay, so what I want to show you is you can convert between the two. So we're going to create a string example, and we're going to convert this string to a character array C by using this method call, which simply converts it to that character array. And you can see, I mean, it's still going to output similarly, but I'll show you it's been converted to C-string. Alright. And we'll look at this running real quick. There it is. Okay, so the other way around is by saying you can also convert it, and it's pretty easy to convert it from a C string to a string, right? We're going to go ahead and take a character array, which is a string, raw equals raw input, and we can just simply implicitly convert it that way. So it automatically boxes that into a string, if you were. And to make it a little bit confusing, this is often called a C++ string, but I mean, I often call it the modern strings, and we will say converted here. Alright, and yeah, let's just show you that running. Alright, just remember C underscore str, so this particular thing here, this C underscore str, only gives you a read-only pointer. So you need to use that constant char to convert that. If you don't have that pointer there, it should give you an error, and it does. It gives you the error there that says cannot be used to initialize an entity of type constant char, right? So you need to have just a single pointer to that, or it will not work. So use strings for most C++ programs. C-style strings are still useful for low-level operations and APIs. The modern strings are easier to work with and safer. Be mindful of buffer size when using char, and convert between types using C-string or assignment. Alright, that pretty much wraps up this part of the chapter. In the next chapter, we're gonna look at structs, and then we're gonna come back and address next week some multidimensional arrays and what pointers are doing. So yeah, just keep in touch, and keep working, and we'll talk to you soon.